Hi everyone, we're going to do some examples of derivatives of logarithms. This is part 2, and I have 6 problems here. That's supposed to be a parentheses. So if you already know how to do some and you just want to look at and scroll through the others, that way you know which one specifically you might want to do. So the first one is here, and we're going to use the power property or the chain rule. And so it's going to be 3 times log base 2 of x times the derivative of my inner function, which is log base 2 of x. So we're taking the derivative of that. Now we're going to get 3 times log base 2 of x. And the derivative of this, remember, is 1 over x times log, 1 over log of 2. Now, cleaning this up, we're going to get, let's see, when we clean all this up, we're going to get, this goes in the numerator. So we get 3 log base 2 of x over x times, log 2. All right? The next one is with secant and tan. So the first thing I'm going to do is take the derivative of log. And this will be to the first power. So when you take the derivative of the log, whatever is here, that's like 1 over x. So our x happens to be all of that. So that's going to be 1 over tan x plus secant x. And then you're going to multiply it by the derivative of, this is your inner function. So I'm just going to write that out for now. Now I got to take the derivative of that. The derivative of that's going to be, let's just write this out, 1 over tan x plus secant x, and the derivative of, so this is times, derivative of tangent is secant squared, and derivative of secant is secant times tangent. And then all you're going to have to do is we can factor out the secant. I'm going to put all this in the numerator. So when you factor out a secant of x, you're going to get secant of x plus tan of x over our denominator, which is tan of x plus secant of x. What's nice about this is these two are the same, so they cancel out. So my derivative is just going to be secant x. The next one we have is this one. So again, when I take the derivative, of log, that's just going to be 1 over whatever the quantity here is. That would be your x part. So that's just be x plus square root of x squared plus 1. So we took the derivative of log. Now we have to do the inner function, which is going to be x plus the square root of x squared plus 1. And we want to take the derivative of that. So let's go ahead and do that. And I'm going to go ahead and put this in the numerator to save some space here. Derivative of x, oh, by the way, this right here is just going to be x squared plus 1 to the 1/2. So again, the derivative of my x is just 1 plus, and then we use the chain rule. So 1/2 x squared plus 1 to negative 1/2, and then you times the derivative of the inner function on that one, which is 2x. And we still have this all over this. So we have x plus the square root of x squared plus 1. So if I rewrite this, it's a complex rational. I'm going to have a 1 plus, I'm going to write this part, So this is going to be 1, basically. Oh, this is a 2x here. So 2x over 2 times x squared plus 1 to the 1/2, or it's actually the square root. And this is all over x plus square root of x squared plus 1. Now if I get my common denominator for my numerator is just that. So I'm going to go ahead and cross here. I'm going to make my whole denominator for my numerator to be this. I'm going to go ahead and write this as x squared plus 1. And then I'm going to have to multiply that. So that's going to be 2 times x squared plus 1 plus 2x. And this is all over x plus the square root of x squared plus 1. All right? And so what's going to happen is, let's see, actually, this wasn't 2x, this was just the, oh yeah, this was 2x. Okay, so basically, I'm kind of overworking myself. Real quick, let me do something real quick before I do this. I'm going to cross out the 2's here and then do this because that's making things a little difficult. So now when I do that, I'm still going to have my, my denominator is going to be square root of x squared plus 1 because the 2's cancel out here. And when I cross multiply, I'm going to get square root of x squared plus 1 and then just plus x. Okay, so sorry about the delay there. Now, if you notice, these 2 cancel out. These 2 are the same. So basically, you can move this guy up here, and these would cancel out, and that would leave 1 on the numerator. So that's going to be 1 over square root of x squared plus 1. Okay, next one is this one. And so what we're going to do with this is just expand it first. So expanding it, recall with, okay, we're going to expand this and write it as a difference of logs. And with that, we have to use absolute value given the domain of logarithms. So this would be minus log of x plus 1. Now, knowing the derivatives of absolute values, we're going to do, this is 1 over x, so this is the derivative. It's just going to be derivative of this over x minus 1. And then this is going to be minus derivative of x plus 1 over x plus 1. And that's the derivative. And so what we're going to get is 1 over x minus 1 minus 1 over x plus 1, because the derivative of this function is just 1, and the same with that one. Now, common denominator is x minus 1 times x plus 1, so that's going to end up being x plus 1 minus x minus 1. And that's going to give you, blah, blah, blah. This is going to end up, the x's are going to cancel and you're going to get 2. This right here is just x squared minus 1. And that's all. And let's do this one. This one's not as complicated. We do have a base a there, which is 10 in this case. So when you take the derivative of that, that's just going to be 1 over x squared plus 1 times 1 over log times 10, or log of 10. Then you take the derivative of this function. So what we're going to end up getting is, and this is all the derivative, the derivative of this is just 2x. and you're going to get x squared plus 1 times log 10. And for our last one, we have this one here, and it's very similar. So what we're going to do is take the derivative of x times log our second function, and then we're going to multiply x times the derivative of log of x squared plus 1, and we take the derivative of that. So what we end up getting is the derivative of x is just 1, so we get log times x squared plus 1, and then plus x, and we take the derivative of this. So derivative of this, remember, that's just going to be 1 over x squared plus 1, and the derivative of the inner function is 2x. So I'm just going to put this as 2x. So basically, if you simplify this, you'll get log of x squared plus 1 plus 2x squared over x squared plus 1. And that's all. Thank you. Have a nice day. Bye-bye.